Let's talk about binary. In our daily lives, we count in a system called decimal. It is a base 10 system. And that means any value in the system will have a value of 0 to 9. Binary is a base 2 system that's used by computers, and it means that any value in the system will have only two possibilities, a 0 or a 1. A bit. A bit is a digit in the binary system. Again, this can only be a 0 or a 1. A byte is 8 bits. It's an 8-digit binary number like 0101, 0101. And if you wrote every possible combination of zeros and ones, you would get 256 possible combinations. Therefore, 1 byte can store values from 0 up to 255. All computer hardware stores, reads, and writes binary data in bytes. Conventional monitors use 1 byte for each primary color and its shades, and this is why your monitor has a max of 256 colors. So, this is a standard color palette for a standard color monitor. Those are all the colors and shades of different colors that could be used on a standard color monitor. Do you think that's enough shades of gray? I mean, what's it go from 232 up to 255, 256? You think that'll be enough gray for a medical image? No way. Not even close. We need all of the possible colors to be shades of gray. For example, if you look at this image here, this area that I'm going to trace and outline for you, if you see that distinctive shape, that's the patient's right kidney, right? But if you look over here, you see this line that comes down and goes around like this? That's the outer margin of the liver. The liver, actually, this big area I'm tracing now. So that's the edge of the liver. That's the kidney right there. So those are two slightly different shades of gray that through years of practice of looking at images, I can distinguish between those two shapes inside the body, but they're very close shades of gray. Which is why you can't have too much gray. And the reason we use special black and white barcode monitors is that all the bytes can be assigned to shades between black and white. You can have all of those color palette blocks, those bytes, equal different shades of gray. So is it bits or is it bytes? Data storage is expressed in bytes and uses an uppercase B. Right? So you've got a bit, a byte, 8 bits. You've got a kilobyte, 1,000 bytes. 1,000 kilobytes is a megabyte. 1,000 megabytes is a gigabyte. 1,000 gigabytes is a terabyte. 1,000 terabytes is a petabyte. 1,000 petabytes is an exabyte. And 1,000 exabytes is a zettabyte. 1,000 zettabytes is a yottabyte. It gets kind of silly there at the end, doesn't it? I mean, who comes up with these things? Zettabytes, yottabytes. It has kind of a yabba dabba doo byte thing going on there. Is it bits or bytes? Network data speed is expressed in bits and it uses the lowercase b. 1 kbps is 1,000 bits per second. 1 mbps is 1,000 kilobits per second or 1 megabit per second. 1 gbps is 1,000 megabits per second or 1 gigabit per second. So those are bits for network speed. So, binary versus decimal. Multiples of bytes can be counted in two slightly different ways. Because binary is a base 2 system, a kilobyte expressed in binary is 1,024 bytes. However, because decimal is a base 10 system, that same kilobyte expressed in decimal is 1,000 bytes. And so people always argue about, well, whether it's 1,000 or is it 1024, and it really just depends on whether you're talking binary or decimal. If you're talking in binary, right, a kilobyte is 1,024 bytes. If you're talking in decimal, a kilobyte is 1,000 bytes. And if you need to see the math, it's right here. So here you have binary, all zeros and ones. So it's a base 2 system. So you have 2 to the 10th power gives you 1024. If you're working in decimal, a base 10 system, the math adds up to be 1,000. So wait, is it 1,000 or is it 1024? Well, Again, it depends on whether you're expressing it in binary decimal. I don't want to beat that point to death, but this gets people confused all the time. So, a bit is a 0 or a 1. A byte is 8 bits. A kilobit is 1,000 bits. A kilobyte in binary is 10,024 bytes. A kilobyte expressed in decimal is 1,000 bytes. From kilobytes, we go on to megabits and bytes. Right? A megabit is 1,000 kilobits. A megabyte is 1024 kilobytes in binary. A megabyte is 1,000 kilobytes in decimal. And from mega, that sequence repeats in gigabits. So, how does all this relate to data storage? Well, any data can be stored in either text format or binary format. So things that are best stored in text are names, dates, addresses, things that humans need. Humans need to know names, humans need to know dates, humans need to know addresses. Those are best stored as text so that humans can read them. Numerical sequences and strings are usually stored as binary. Now, the problem with binary encoding is that there's two ways to do it. As you may have guessed over your lifetime, Microsoft uses one format for binary encoding and Apple uses the other. And this is why Apple and Microsoft don't play nicely together. Those are called Big Endian versus Little Endian. Please don't say Indian. And the word Endian comes from the book Gulliver's Travels. If you've read that book or you want to go read it, it's a great book and you can learn all about the Endians. So, some computers write data from left to right, and that's called Little Endian. Other computers write data right to left. That's called Big Endian. So 1987, if it was expressed in Little Endian, would be 1987. Simple. But here's the trick. In Big Endian, it's 7891. So that's why Microsoft and Apple don't play well together, because one uses Little Endian and one uses Big Endian. And clearly this is a problem if the CT scanner is trying to talk to the PAX system. They need to be speaking the same version of Endian. So Endianness gets worked out at the DICOM handshake. When they first make a connection, one of the first things they start to figure out is, hey, what version of Endianness are we going to use for this communication? The DICOM standard states that all systems must be able to understand and process Little Endian. So Little Endian is the go-to for two DICOM things speaking to each other. Now, they may prefer Big Endian and they may use Big Endian if they both speak Big Endian. But if they don't have a way to speak to each other, they should always be able to do it at the very least in Little Endian. Thank you for watching.